Hi guys, welcome back to Technowizard. So let's start with today's session. So let's see our first question. So this is our first question, and this is our first question. In the interconnection of the ideal sources shown in the figure, it is known that the 60-volt source is absorbing the power. Which of the following can be the value of the current source I? So basically, it is in the question, it is saying that the 60-volt source is absorbing the power. It means the current must enter the positive terminal of the voltage source, then only it will be absorbing the power. If the current is in the outward direction, then this source will be delivering the power. But in this question, it is saying that the 60-volt source is absorbing the power. It means the current must enter the positive terminal. So let us assume this is current I1. So we have to find out the value of the current source. So let's apply the KCL at this node. So if we apply the KCL at node A, to KCL states that the sum of incoming current is equal to the sum of outgoing current. So at the node A, incoming current is I plus I1. It means the current I plus current I1 must equal to the outgoing current, which is 12 ampere. So see here, so the sum of both the currents should be equal to 12. It means both the current I and I1 value should be less than 12. Then only this equation will be satisfied. So see the option. In the option all B, C and D, in option B, C and D, both all the values are greater than 12. So this equation will not hold. So correct option is A, because when current source I value is 10, then only this equation will hold, right? So for this question, option A is correct. So let's see our next question. So this is our next question. The currents I1 and I2 in the below circuit are respectively. Okay, so basically they have given us a circuit and we have to find out the value of current I1 and I2. So basically this is a super mesh. So this is a super mesh. So a super mesh is a network in which a current source is present in between the two meshes. So let's first understand what is mesh and what is loop, right? So a mesh is a smallest possible loop which does not contain any inner loop. So see this. So this is one mesh and this is another mesh which don't contain any inner loop, right? So here two mesh are present, which is M1 and M2. But if we consider loop, so in this network or circuit three loops are present. So this is loop 1, this is loop 2, and the outer one is loop 3. But the loop 3 can't be considered as mesh because it contains two inner loop. So here loop are 3, right, which is L1, L2 and L3, right? So it is saying that we have to find out the current I1 and I2. So here this is forming a super mesh. So what we have to do is we have to apply the KVL in the outer loop, right? So we are gonna apply the KVL in the outer loop, right? So here current I1 is flowing like this. So this terminal will be positive because current I1 is flowing like this, and this will be negative, right? And similarly current I2 is also flowing like this. So this will be positive, this will be negative. The terminal at which current is entering will be considered as positive. So this will be positive, this will be negative. Similarly this will be positive, this will be negative. Now we're gonna apply the KVL at the outer loop, right? So which will be, so we'll start from here. So first sign that we are countering is minus, so it will be minus 40. So next will be plus 2I1, next will be plus 1 into I2, which will be simply I2. Next will be 4 into I2, next will be 3I1, that will be equal to 0. So after simplification we will get, so it will be 5I1 plus 5I2 is equal to 40. It means I1 plus I2 is equal to 8. So this is equation 1. Now second equation will be developed around the current source. See here, the current I2 the current I2 is in the upward direction, but the current I1 is in the downward direction. Okay, and the net current is in the upward direction. It means I2 current is dominating than I1. So the equation will become I2 minus I1 will be equal to the value of current source, which is equal to 4 ampere, right? So this will be equal to 4 ampere. So this is equation 2. So after simplifying equation 1 and equation 2, so equation 1 was I1 plus I2 is equal to 8. So this was equation 1. Now adding both the equations, so I1 get cancelled, so it will be simply 2I2 is equal to 12. So I2 value is coming as 6 ampere. So from here we can find, from the equation 1 we can find out the value of I1, which will be equal to 8 minus I2, which will be simply 8 minus 6. So I1 value is coming as 2 ampere. So see the option. So I1 value is coming as 2 ampere and I2 is coming as 6 ampere. So option C is correct. So let's see next question. Okay, so this is our next question. For the circuit shown, find out the current flowing through the 2 ohm resistance. Also identify the changes to be made to double the current through the 2 ohm resistance. So see here, these three branches are connected in parallel. So we know that in parallel the voltage remains same. It means the voltage across the 2 ohm resistance is 4 volt. So we have to find the current through 2 ohm, which will be simply V by R. So voltage across the 2 ohm resistance is 4 volt, right? And resistance value is 2 ohm. So current through the 2 ohm resistance is 2 ampere. Now it is saying that identify the changes to be made to double the current through the 2 ohm. So if we have to double the current through 2 ohm, it means the value of current will become 4 ampere. So obviously the voltage source has to become 8, then only the current will become double. So option B is correct, right? So let's see our next question. Consider the following figure. The current I of S in ampere in the voltage source and the voltage V of S in volts across the current source respectively are. So basically we have to find out the value of current IS and VS. So see here, so this 10 volt and this 2 ohm resistances, they are connected in parallel. It means the voltage across 2 ohm resistance is 10 volt. So the current through 2 ohm resistance will be 10 by 2. It will be simply 5 ampere. So from here the current entering will be I of S plus 5. Now this 1 ohm is also connected in parallel with the 10 volt. So the current in 1 ohm resistance, because this is in parallel with the 10 volt, so current will be 10 ampere. So applying the KCL at this node, here current 10 ampere is flowing and here highest plus 5. So it will be simply I of S plus 15 ampere. Now we will apply the KVL in outer loop. So we will apply the KVL like this. So from there we can find the value of I of S. So current is flowing like this, so this will be plus, this will be minus. Now this will be plus, this will be minus. So we can simply write the KVL equation. It will be minus V of S plus. So we can also see from here that the current in this branch, so the current in this branch is IS plus 15 and here the current source of 2 ampere. It means I of S plus 15 is equal to 2 ampere. So from here the value of I of S is coming as minus 13 ampere. Now we have to find out V of S. So now we will apply the KVL in outer loop. So it will be minus V of S, so plus minus V of S, I'm starting from here, then it will be plus 5 into current is I of S plus 15, which is 2 ampere, right? Then this 1 ohm resistance and the current is 10 ampere, so it will be 10 is equal to 0, so it will be minus v of s plus 10 plus 10 is equal to 0, so v of s value is coming as 20 volt. So for this question option B is correct. Next it is saying that the current in the 1 ohm resistor in ampere, so we have already calculated the current in the 1 ohm resistor is 10 ampere because it is connected in parallel with a 10 volt source, right? So for this question C is correct. Let's see next question. So next is this question. So next question is this: in the above circuit, V1 is equal to 40 volt when R is 10 ohm. When R is 0, the value of V2 will be. So basically in this question it is given that when the value of V1 is 40 volt and V1 value is 40 volt when resistance R is 10 ohm, right? So it is saying that when the resistance value is 0, it means when R is short circuited, we have to find out the value of V2. So simply draw this circuit. So this is 60 volt source, right? So it is 60 volt. Now it is given as 10 ohm, this is 20 ohm, and this is short circuited as they have already said because resistance R is 0. So now this is 20 ohm and this is 10 ohm, this is 20, and a current source of 5 ampere is connected here. This is 20 ohm, this is 10 ohm, this is 20 ohm, this is 20 ohm, and this is 10 ohm. So this voltage is V1, this voltage is V2. So here the value of V1 will be equal to V2 because there is no resistance and hence no voltage drop will be there. So that's why the value of V1 will be equal to V2. So simply we can find the value of V1 by applying the voltage division rule. So by voltage division rule we can find the value of V1. So V1 is equal to, here the total voltage is 60 volt and V1 is the voltage across 20 ohm resistor. So 20 divided by sum of both, that is 10 plus 20 is 30. So it will be simply, so V1 value is coming as 40 volt and V1 is equal to V2 because resistance is 0, so there will be no drop, hence V2 value will also be 40 volt. So for this question option A is correct, right? So let's see next question. So this is next question: the current through the branch AB in the figure shown is. Okay, so basically we have to find out the current through the branch AB, that is current through the 2 ohm we have to calculate. So let's first assume the voltage at the node A is V1 and the voltage at the node B node is V2, right? So V2 value is already given in the question because these two branches are in parallel and in parallel voltage remains same. So V2 value is already given, which is equal to 20 volt. So we have to apply the nodal at A node. So in the nodal we consider the current in the outward direction, right? So I'm gonna apply the nodal at node A, right? So we have to consider the current in the outward direction, so it is in opposite, so it will be minus 10 plus V1 by 2 plus V1 minus V2. V2 value is already 20, right? Divided by 2 is equal to 0. So taking the LCM, so it will be minus 20 plus V1 plus V1 minus 20, so that is equal to 0. So 2V1 is equal to 40, so V1 value is also coming as 20 volt. It means here V1 is equal to V2 is equal to 20 volt. It means these two nodes, node A and B, they both are at the same potential and hence no current will flow through the 2 ohm resistance because for the flow of current potential difference is must, but here there is no potential difference, so there will be no current through the 2 ohm resistance, right? So current through the 2 ohm will be V1 minus V2 by 2, but here the difference is 0, so the current through the 2 ohm resistance is 0 ampere, right? So for this question option C is correct. Next question is: in the circuit shown in the given figure, the power dissipated in the 5 ohm resistor is, so basically we have to find out the power dissipated in this 5 ohm resistor. So let's apply the nodal. Let's assume this is node A, at which the voltage is V1. This is node B, at which the voltage is V2, and let's consider this is a reference node. So let's first apply the nodal at V1. So we are going to apply the nodal, so we mark the current in the outward direction. So it will be simply -4 plus V1 by 5 plus V1 minus V2 by 10 is equal to 0, right? So after taking the LCM 10, so it will be -40 plus 2V1 plus V1 minus V2 is equal to 0. So it will be 3V1 minus V2 is equal to 40. So this is equation 1. Now applying the nodal at the second node, right? So now applying the nodal at V2, so this will be V2 minus V1 by 10 plus V2 by 4 minus 5 is equal to 0. Minus 5 because we have to consider the current in the outward direction, right? So it will, they are in opposite direction. So now after taking the LCM, it will be 20. So this will be 2V2 minus 2V1 plus 5V2 minus 100 is equal to 0. So this will be minus 2V1 plus 7V2 is equal to 100. So this is equation 2. Now solving equation 1 and equation 2. So solving equation 1 and equation 2. So equation 1 is basically, so equation 1 is 3v1 minus v2 is equal to 40. This was equation 1, and equation 2 was minus 2v1 plus 7v2 is equal to 100. This was equation 2. So multiply equation 1 by 7 so that we can eliminate v2. So this will be 21v1 minus 7v2 is equal to 280. Now adding equation 2 and 3. So adding equation 2 and 3 we will get, so this will be 21 minus 2, it will be 19v1 minus 7v2, and plus 7v2 will get cancelled out, and this will be 280 plus 100 will be 380. So v1 value is coming as 380 by 19, which is equal to 20 volt. So what we have to find out in the question, so in the question we have to find out the power dissipated in the 5 ohm resistor. So power dissipation formula is given as v square by r. So here the power dissipated in the 5 ohm resistor is given as V1 square upon R. So V1 is the voltage across that resistance, which is 5 ohm. So here V1 square is 20 into 20 divided by resistance value is 5. So it will be simply 80 watt, right? So option B is correct. So let's see next question. Okay, so this is next question, the voltage E naught in the figure. So in this figure we have to calculate the value of E naught. So we can find out this by the nodal. So let us assume the voltage at this node is V1 and the voltage at this node is V2. So we have to simply apply the nodal. So let's apply the nodal at V1. So the current in the outgoing direction is like this. So it will be simply -8 plus V1 by 10 plus V1 minus V2 by 2 is equal to 0, right? So after taking the LCM, it will be 10, so it will be minus 80 plus V1 plus 5V1 minus 5V2 is equal to 0. So it will be 6V1 minus 5V2 is equal to 80. So this is equation 1. Now applying the nodal at the rate V2. So now the current will be like this in this direction, right? So it will be simply V2 minus V1 by 2 plus it will be V2 minus 16 by 6. Here minus 16 because the current is flowing like this. The nodal current we have marked like this, but this 16 volt will deliver the current in upward direction. So both the currents are in opposite direction. So that's why it will be minus 16 divided by 6 and plus it will be V2 by 12. So that is will be equal to 0. So after taking the LCM 12, so it will be 6V2 minus 6V1 plus 2V2 minus 32 plus V2 is equal to 0. So this will be equal to minus 6V1 plus it will be 3, 6, 7, 8 and 9V2. 9V2 is equal to 32. So this is equation 2. Now adding both the equations. So now adding both the equation. So both the equations are 6v1 minus 5v2 is equal to 80. So this was equation 1 and minus 6v1 plus 9v2 is equal to 32. So this was equation 2. Now adding equation 1 and equation 2. So 6v1 minus 6v1, that both will get cancelled out, and minus 5 plus 9, so that will be 4v2 is equal to 80 plus 32 will be equal to 112. So v2 value is coming as 112 by 40, which will be equal to 20. So v2 value is coming as, v2 value is coming as 28. So this will be 8. So v2 value is coming as 28 volt, right? So let's see what is asking in the question. So it is saying that we have to calculate the voltage E naught. Okay, so voltage E naught is the voltage across 12 volt and they both are connected in parallel. It means E naught is nothing but the value of V2, right? Because they both are in parallel, hence the value of E naught is coming as 28 volt, right? So E naught is equal to V naught V2 because they both are in parallel, hence V2 value is coming as 28 volt. So hence option D is correct. So let's see next question. So this is our next question, and the current Ix and the voltage Vx in the below circuit are respectively. Okay, so basically we have to find out the value of current Ix and the voltage V of x. So this will also be done by the nodal. So let us assume the voltage at this node is V1 and the voltage at this node is V2. Alright, so let's first apply the nodal at this node. So let's mark the current in the outward direction, right? So it will be simply minus 7 plus V1 by 5 plus the current flows from high potential to low potential, so it will be V1 minus V2. Now this 20 volt will deliver the current in this direction which will oppose this nodal current, so it will be minus 20 by 10 is equal to 0. So now taking the LCM, it will be 10, so it will be minus 70 plus 2v1 plus v1 minus v2 minus 20 is equal to 0. So it is coming as 3v1 minus v2 is equal to 90. So this is equation 1. Similarly, applying the nodal add to the second node. So let's do this in the next slide. So it will be v2 minus v1. It will be, if we are applying the node at the second node, so it will be v2 minus v1 plus 20, because this 20 volt will deliver the current in this direction, which will add with the nodal current, right? So suppose this is our nodal current in the outgoing direction, so it will be simply v2 minus v1 plus 20, because it will support the current, nodal current, and it will be v2 by 3 plus v2, and this 20 volt will also support this current, so it will be plus 20 by 2 is equal to 0. So after taking the LCM, so it will be, so LCM will be 30, so LCM will be 30, and it will be 3v2 minus 3v1 plus 60 plus 10v2 plus, it will be 15v2 plus, it will be 300, that is equal to 0. I hope you can adjust, guys. So the equation will become minus 3v1 plus, it will be 25 plus 3 is 28v2, and this will be is equal to minus 360. So this is equation 2. Now adding equation 1 and 2, we can find the value of v2. So now let's add both the equation. So equation 1 was 3v1 minus v2 is equal to 90, so this was equation 1. Equation 2 was minus 3v1 plus 28 of v2 is equal to minus 360. So now add both the equation, so it will be 27 of v2 is equal to minus 270. So v2 value is coming as minus 10 volt, and in the question we have to find out, so we have calculated the value of v2. Now we have to find the value of current ix. So current ix will be simply v2 plus 20, because current ix is flowing like this, so it will be v2 plus 20, because it gonna support divided by 2, right? So yeah, now we have to calculate the value of ix. So I of x is simply v2 plus 20 volt divided by resistance 2, so it will be minus 10 plus 20 by 2, that is 10 by 2. So current value is coming as 5 ampere, so it will be 5 ampere. Now we have to calculate the voltage vx. So v of x is the voltage across 2 ohm, so voltage will be 2 into ix, right? So voltage v of x value is 2 into I of x, so it will be simply 2 into 5, so it will be coming as 10 volt. So so and option A is correct, right? So let's see next question. So next question is this: consider the following circuit. What is the power delivered to the resistor R in the above circuit? So basically this is a bridge circuit, and let's see whether the bridge is balanced or not. A bridge is said to be balanced when the product of opposite arm is equal. So in this bridge, the opposite arm are this and this, and they both are opposite, right? So their product is 30 into 120 is equal to 60 into 60, so their product will be 3600 is equal to 3600. It means our bridge is balanced, right? And when a bridge is balanced, so no current will flow from here, because these two nodes will be at the same potential, and hence no current will flow, as a result of which power delivered to the resistor R will be 0, right? So 0 watt. So option B is correct, because the bridge is balanced and hence no current will flow, so as a result no power will be delivered. So let's see next question. Okay, so this is our next question. Okay, so in the circuit shown, when the current through the branch AD is 0, the battery current IB is. Okay, so in the question it is saying that the current through the branch AD is 0, so the current through the branch AD will be 0 when the bridge is balanced, then only the current will be 0. It means in the question they have already mentioned indirectly that the bridge is balanced, so for that the product of opposite arm must be equal. It means product of opposite arm is resistance R into 80 is equal to 80 into 120. From here we can calculate the value of resistance R is 120 ohm, right? So now we have find the value of resistance R is 120. Now we will simply draw the bridge circuit. So now our bridge circuit will be like, so this is 120 ohm resistance and this is 80, this is 120 ohm resistance R whose value we have calculated. Now this is already 120 resistance and this is 80 ohm, this is 120 ohm. Now the current through the galvanometer is 0, it means this is open circuit, no current will flow, right? And now the battery is like this. I think they have misprinted the battery polarity because this is positive, so this must be longer, right? So they have misprinted this, right? So this is IB current whose value we have to calculate, and this is 1 volt. Now these two will be in series, so 120 plus 80 will be 200, and this will also be 120 plus 80 is 200. It means 200 in parallel with 200, right? So now our circuit will be like, it will be 200 because both the resistances will be in series, and similarly this is also 200 ohm. Now a battery of 1 volt is connected there and the current IB is flowing. Now these two value will become, it can be reduced to 200 into 200 divided by their sum, so it will be simply 100 ohm, right? So we can calculate the value of IB is V by R equivalent. So voltage is 1 volt and R equivalent value is 100 ohm, so it will be simply, we have to find the answer in milli, so we can multiply with 10 to the power minus c, so it will be simply 10 milliampere, right? So option C is correct. Okay, so let's see next question. Okay, so this is our next question. The circuit shown in the figure 1 is replaced by that in figure 2 if the current I remains the same, then R naught will be. Okay, so in the circuit, it is in the question, it is saying that the figure 1 and figure 2, they both are same and the value of current I will remain same, so it will be only possible, so the value of current I will remain same when the resistance value will remain same, because here the voltage is same. For the current to remain same, the value of resistance must be equal. Now these three resistances are in parallel, and in figure 2 also these three resistances are in parallel, which is connected in series with R naught. So now we have to find out the value of R naught. So so for the figure 1 we have to calculate the value of R equivalent. So when the three resistances are connected in parallel, suppose this is resistance RA, this is resistance RB, and this is resistance RC, this is resistance RB, and this is resistance RA, and we have to calculate the value of R equivalent, so which is given by the formula. So R equivalent is equal to, is, it will be simply given by RA, RB, RC divided by RA, RB plus RB, RC plus RC, RA. This formula will be used to calculate the value of R equivalent when the three resistances are connected in parallel. So here three resistances are connected in parallel, so we'll calculate the value of R equivalent, right? So here the value of RA is 32R, RB is 16R, and RC is 8R. So simply put the formula. So R equivalent is equal to 32R into 16R into 8R divided by, So RA into RB will be equal to 32R into 16R plus it will be 16R into 8R plus 32R into 8R. Now we can simplify this equation, right? So R equivalent will become, so R equivalent is equal to 32 into 16 into 8 into R cube. So from the denominator I have taken R square common, so which will be 512 plus, after multiplication I will get 128 plus 256, then it will be 32 into 16 into 8 into, so R square, and this will cancel, so R will be remaining, right? And this will be 896. So we are getting the value of R equivalent as 32 by 7R. So it will be 112, right? So from here we can calculate, and this will be 7. So from here we have calculated the value of R equivalent is equal to 32 by 7 of R. Similarly from the figure 2 also we can calculate the value of R equivalent, and then we will add plus R naught. So let's calculate the value of R equivalent, right? So here R equivalent, this is 1, this is 2 will become, so it will be simply 4R in parallel with 2R in parallel with R divided by 4R into 2R will be equal to 8R square, plus this will be 2R square, and this will be 4R square. So this will be simply for 8R cube divided by 14R square. So this will be 4 by 7. So R equivalent 2 will be equal to, so this will get cancelled, so it will be 4 by 7 of R and plus R naught, which was connected in series. So this was equation 2. Now the value of R equivalent 2 is coming as this. Now let's equate both the equation. So equating equation 1 is equal to 2. Equation 1 we have obtained as R equivalent is 32 by 7 of R, and equation 2 is 4 R by 7 plus R naught, because R naught is connected in series with the 3 resistances. Now we have to calculate the value of R naught, which will be equal to 32 by 7 of R minus 4R by 7. So it will be simply 28 by 7 of R. So R naught value is coming as 4R. So for this question option D is correct, right? So do remember this formula. This formula is important in case of three resistances connected in parallel, right? So let's see next question. Okay, so this is our next question. In the circuit shown, the power supplied by the voltage source is, okay, so basically this, in this circuit we have to calculate the power supplied by the voltage source. Suppose this is a voltage source and this voltage source is supplying the power. It means the current must flow out from here, then only it will supply the power. If the current is in opposite direction, then this voltage source will be absorbing, right? But it is supplying the power, so the direction of current will be like this. So from here 1 ampere current is coming, and from here 2. So applying the KCL at this node, so from here 3 ampere current will come. Now from here I ampere current is coming, and from here 3 ampere current, so both will add and it will be I plus 3. Now this I plus 3 current is coming. Now 1 ampere has gone to this side. It means here I plus 2 ampere current is flowing, and this I plus 2 current will come from here, and 2 ampere has gone. It means current I is flowing. So it means our branch current is correctly divided. Now we have to apply the KVL, so we will select the loop. So we can't apply the KVL in this loop because there is a current source present and we don't know the voltage across this current source, so we can't apply. Similarly, we can't apply in this loop also, and we can't apply in this loop also. So the loop which is remaining is the outer loop, so we will apply the KVL in the outer loop because there is no current source present in the outer loop, right? So we will simply apply the KVL in the outer loop. Now here in 1 ohm the current is flowing like this, so current is entering from here, so this terminal will be positive and this terminal will be negative. Similarly, in this 1 ohm resistance also current is entering, so this is positive, this is negative. Similarly, this is also positive and this is negative because current is entering like this, so this will be positive and this will be negative, and they are in series, so it will be simply 2 ohm, right? So now we are going to apply the KVL in this loop. So we'll starting from minus polarity, so it will be minus 10, so plus it will be simply 1 ohm and 1 ohm, so it will be simply 2 ohm because they are connected in series. A current of I plus 3 is flowing from them, right? Similarly, these 2 ohm 1 ohm resistances are also in series, so it will be 2, current is I plus 2 is equal to 0, so it will be minus 10 plus 2i plus 6 plus 2i plus 4 is equal to 0, so it will be 4i, so it will be minus 10 plus 10 is equal to 0. It means they both will cancel, so the value of current I is coming as 0. So the power supplied by the voltage source is voltage into current. So voltage is 10 volt but the current is 0, so the power supplied by the 10 volt source is 0 watt, right? So for this question, option A is correct. So that's it for today's session. See you in the next lecture. Till then, bye.